Some students have question about the assignment 6.2. Prove that if A is a proper subset of C and A is subset of B and B is subset of C, then either A is a proper subset of B or B is a proper set of C. Since you have logic OR, there could be both true. Now let's first clarify this concept. Okay, normally A is a proper subset of B, which means in this scenario, if you're a visual thinker. But now if A is a subset of B, but at the same time, if it's not a proper subset of B, in fact, that actually means A, B are the same, equal B. So it's this situation. Basically, A, B are the same, but we can still say A is a subset of B, and also B is a subset of A, because the definition of subset actually says if X belong to A, it also belong to B. So therefore, A is a subset of B, but it didn't say. So this is the situation. Now, in our situation, if we only say A is a subset of the B, B is a subset of the C, could also be in this for situation. Not in general, you understand this. A is inside B and B altogether inside C. That's sort of good imagination. But it could also be this. So, and A is subset of B, but not proper subset or improper subset, but B and A actually are the same, but they together be subset of C. That could be still true if you just say this. And it could also be this. A is a subset of B, but B is a subset of C, but B actually equals same as C. So this still holds. And could be in this situation. Okay, A is subset of B, and B is subset of C. All three are equal and are the same situation. So just have this doesn't mean just this. Okay, these are, if you can think about it, these are the nice subsets, but these are subsets, but actually they are equal. Some of these are equal. Now let's prove it with mathematical language. Okay, by the definition of proper subset, at least one element in C not belong in A. That's how we interpret this. Okay, at least one element in C not in A. Let's denote that particular element as CA not. We can write this. CA not, that particular one not in A, called this not belong to A. Now suppose the contrary is true. What contrary is true? That is not true. Okay, and which means A is a proper subset of B, or B is a proper subset of A. Suppose that is not true. Okay, I'm going to prove it by contradiction. So by De Morgan's law, this statement or that statement, that equals A is not a proper subset of B, and B is not subset of B. And here is the end due to De Morgan's law. Now, and this is the given. A is actually a subset of B, and B is actually a subset of C. And with these two, as we have just discussed over here by visual, and that's this situation. Therefore, A is actually equal to B, operate B equal to A. At the same time, with these two, we can conclude that B is actually equal to C, and C is actually equal to B. So A equal B, B equal C, therefore C equal A. That's general common sense. And then if C is actually equal to A, then any elements in C, including that particular one, CA bar must belong to A. Okay, excuse me, I missed one. Must belong to A. So must in A. So therefore, you see the contradiction. So that particular one must in A. But here we assume that at least one not in A. So if we assume contrary is true and will lead to a contradiction. So therefore, the assumption proved. So for proved. So the end. Hope you get it. Okay, let me know if you still have a question.